Back at it again. Last time we were here, we were talking about accuracy and precision. I think we need a quantitative tool that will allow us to judge the accuracy of the measurements that we make, especially when we're making measurements that we can compare to an actual or a known or a true value. These are sometimes referred to as theoretical values or calculated values. We're going to use the tool of percent error, which is a simple equation that we can use to estimate our accuracy. Here's the equation. It says percent error is equal to the absolute value of the theoretical value, also known again as the true value, or the published value, or the accepted value, or the known value. Any of those are synonyms, minus the experimental value, what we measured, over that theoretical value, and multiplied by 100 to turn it into a percentage. Let's see if we can put it into practice. I have a problem here that says a sample of wood has a density of 0.85 grams per milliliter. I'm going to assume that this is the published or the theoretical value. It's telling me that is the density of that piece of wood. In the lab, you measured the density to be 0.91 grams per milliliter. This is what's known as the experimental value because we measured it. You measured it. It says, what's the percent error in your answer? I'm going to write down our equation again. Percent error is equal to the difference between really the absolute value of, let's go back and look at it, the theoretical value minus the experimental value. Now, I'll be honest, because we're taking the absolute value, if you get this order mixed up and you do them backwards, that's okay. You're going to take the positive value anyway. We're dividing by the theoretical value, and we're multiplying by 100 to make it a percentage. So in this particular case, my theoretical value is 0.85 grams per milliliter. My units are actually going to all cancel out. I'm not going to even write them down because percent errors never have units. We're dividing by our theoretical value, 0.85, and we're multiplying by 100. Because we're taking the absolute value, we should always get a positive answer. But you'll note, as soon as I say 0.85 minus 0.91, I have a negative value. It's negative 0.06. I'm going to go ahead and make that positive because of the absolute value. And then we're going to divide by 0.85. We'll multiply by 100. And this is going to give us a good estimate of our accuracy. When I multiply this by 100, I get 7%, 7% error. What that means is I'm 7% away from the true value in my measurement. Not bad. Okay, see you next time.